trigonometry identities. So this is sort of like the introduction to trigonometry in grade 12, and we might just need to look at some of the identities we have already learned. The first identity that we learned is the one for tan. This one is a very good identity because it gives you a lot of marks when you are in the exam, especially when during proofs. If you apply this identity, you are most definitely going to get some marks, and tan is equal to cos theta, sine theta over cos theta. That's the first identity we learned. And it's a very simple identity. Whenever you see tan, you can actually change that tan to sine over cos theta. It's straightforward. The second identity is this one, and this one is the first of the serious identities. The sine squared theta plus cos squared theta is equal to 1. Now this identity, as you can see, it just tells us that when we square cos of a number and we add it to a square of sine of the same number, we are always going to get 1. And from this identity, you can then also say, if ever you want to know how you can exchange sine to cos, it's going to give us 1 minus cos squared theta, just the same as cos squared theta is going to give us 1 minus sine squared theta. It's very good to understand that this is the only time where you have the opportunity of transforming a sine to a cos or a cos to a sine, and this identity is quite useful. And sometimes I want people to also understand that sine theta will then become square root of 1 minus cos squared theta, just like cos theta is equal to square root of 1 minus sine squared theta. And you must always keep this in mind, even though the main identity that you need to remember is this one. You need to just remember this one, and the rest are coming from that one. Now, the next identities we are going to look at is the ones that we now get in grade 12. And in grade 12, we have got just a few identities. It's not that there are not many. So the first one is for sine. Let's just say we've got sine, and then it's a plus b, and this will become sine a cos b. And because there's a plus sign there for sine, and you are going to put a plus sign there only for sine. With the signs for when you're looking at the sine does not allow the signs to change on the other side, so it will still be a positive there, but now it's going to start with sine b cos a. Now the other identity, again, it's in terms of sine, but now we're going to have sine a minus b is equal to sine a cos b. Now, because there was a minus on this side and it's sine, it will now change to also become a minus sine b cos a. Then we go ahead to cos. I'm going to come back to this one because there's a very special property, and I'm just making a tail there so that you can see what I'm talking about. If I take the top one, let me just rub out something there. Let me rub out this one, and because I want to, now I want us to look at very carefully. I want us to look at one aspect, and that aspect is this one. Now, if I take this one, and let's say I had sine of two things which are the same. Let's say I say sine b plus b. But usually they use a. I'm just using b just for fun. It means that this sine b plus b, let's try and see, let's apply this identity, and then this will give us sine b cos b plus sine b cos B. And that would allow us then to say this is actually sine B plus B is 2B, right? Sine B is equal to 2 of these ones, sine B cos B. Now you can clearly see that I have used the identity to create what we now call the double angle, isn't it? So, or the compound angles. These ones is a very special property of the identities, and usually when they are writing it, they write it in this fashion. They normally say it's actually sine 2a is equal to 2 sine a cos a, and this is what you'd get. And usually we want to stop. If I want to play around with this formula, I can now, because I know I can play around with it. It's going to be half. I take this 2 to this side. Sine 2a is equal to sine a cos a. And you can see how beautiful it is, because I'm playing around with one identity from this identity here. I played around with it, and I got this one which translates to this one, and this one which translates to this one. So you can actually follow the progress, and all you are doing is you are applying the identity. And remember, I said this is the identity we are using. When the sign has got a positive sign on that side, it must have a positive sign on the other side. Now let's continue with the last identity, and that sorry, not the last, the last identities which we want to look at, and the ones for cos. So we know that cos, if we have got cos A plus B, and the identity says that because it's cos A plus B, it's cos A cos B. Minus, cos will now compel it to have a minus, and then once it has got a minus, you are now going to say sine A sine B, and the one with the negative becomes cos A minus B is equal to cos A cos B plus, because there was a negative on this side for cos, it becomes a plus. But don't worry about these identities, they are provided. I am just writing them down to remind you that these are the identities we are going to use. So this is going to be sine A cos, sine B. Now once we have done that, we go ahead and we do our analysis, and remember I said we are using the one with, because if you say a cos A minus A, it becomes cos 0, so we take the one with the positive. So I am now going to say, what if it was cos C plus C? Do you see that? I'm now applying the identity, which is quite nice, and then it's going to be cos C is minus sine C sine C. It's very funny to use C because it looks like all those things here. So now you are now going to have, this is going to be cos 2C is going to be equal to, now if I look at this one, this is the same as cos squared C minus sine squared C. So basically what they are trying to say is, if you are now looking at your formula sheet, you will be seeing cos 2A is equal to cos squared A minus sine squared A. Now this is perfect. Now I can play around with this, and when I play around with this one, you will see that I can just, remember I said that this cos can be turned into sine. Yes, I'm going to turn it into sine. Let me just remove that that's how it is clear. So I'm going to change the cos into sine. Remember, to change the cos into sine, I will use 1 minus sine squared A. Do you see that? I am now applying a different identity to simplify this identity so that it goes somewhere else. Let's go back and look at which identity we are using. Yes, we are using this identity here. Do you see this? Yes, we are using that identity, and we want to simplify. And remember, we said that cos squared A is actually 1 minus sine squared A. This becomes 1 minus 2 sine squared A. And somebody will say, aha, but I can also play around with the sign. So I can now say, oh, but cos 2A, which is also going to be cos squared A minus sine squared A. But now I'm going to change the sign. So it's going to be cos squared A minus bracket 1 minus cos squared A. And this is going to give us that. Now this will now lead us to say, oh look, if I remove the brackets, I'll have cos squared A minus 1 plus cos squared A, which then gives us cos squared A plus cos squared A is 2 cos squared A minus 1. And then if you look at your formula sheet, you should be able to see that identity right there. So we moved from here. From here we can now say we can get this one, yes, and then from this one we can get this one, and also from this one we can get from this one we can get that one. Do you see that? And again from this one we can also get that one. So the identities are very simple when you are looking at them. You want to see how they are linked, and before you start doing trigonometry, try to play around with this and see whether it will give you something worth your while.